every day. Here we go. Greetings and welcomes, lady. Welcomes? Well, yes, sure. Welcomes to all of you individually. I've got one for each of you. Welcomes to you all. We're talking about a NECAP question 2009, number 22. Our particular score for our school on average was 1.5 out of 4 points earned. For the state of Vermont, it was 1.8 out of 4. So, my guys, we just looked at this a little bit, and I'm wondering, what do you guys have as what's your guess for A? What are some of your possible answers that you're throwing out here? 125. Any other responses? Okay, I've got a few head nods on that, so I'm going to throw some of those there. For B, what did you guys have? 5x plus 50 equals what?
Y.
Equals y, okay. So even though they defined the variable x for baseball caps, you ended up having to come up with your own variable. I see that, okay. I had at least one head nod there. That's a check mark, not a Y or something. And then let's see, for part C, the coach wants to buy, what was your guys' guesses for C?
Is it like after like 5 baseball caps, or?
So you're saying 5 is the tipping point between the companies?
That's what I thought.
Okay. Did anyone else get as far as a solution for this one, or? Okay. All right. Well, let's do this together and see what we got. So part A hopefully is somewhat easy. It says, let's see, a coach will order baseball caps from 1 of 2 companies. Creative Caps charges one-time fee of $50 plus $5 per baseball cap. Happy Hats charges a one-time fee of $30, $6 per baseball cap. So part A asks, how much does Creative Caps charge for an order of 15 baseball caps? So you know that it's a flat fee of $50 plus $5 per hat, and the number of hats is 15. So what do we got there? We have 5 times 15, 5 times 10 is 50, plus 5 times 5. So that's 50 plus 75, I think. And 125, I think I agree with you guys. So that means $125, right? It's always good to bring it back in context of the problem. That's what they charge for 15 baseball caps. Let's see, for part B, I'm going to define some variables. They already defined X for us. X was the number of B-ball, right? Hats, right? Bam. Blah, that's kind of ugly wording there. Or letters, I don't know, that's fine. And Y, it sounds like some of us defined as cost. And what is cost measured in? Your number of souls you have to give up to get these hats, or your right hand dollars. That's the units of measure. And let's see. So for our equation, we want an expression. Actually, they specified expression, so I guess we didn't technically need that. The expression would have just been this left-hand side. If it said equation, it would have had that. But so yeah, I think 5x plus 50 ends up working, right? $5 per hat, where x is the number of baseball hats. So 5x and plus $50 would be fine. We'll write y equals 5x plus 50. I don't think they would mark you wrong for that, I'd hope, but technically 5x plus 50 is all they were looking for since they specified expression. So they might have been trying to avoid having a second variable, but I'm glad you guys get that idea there. And then let's see, part C, it says the coach wants to buy baseball caps from the least expensive company in terms of the number of baseball caps. When should the coach order them from Creative Caps versus the other? Okay, show or explain how you know. So let's see, let me write a second equation. So the other one, Happy Hats, is $6 per hat, right? And plus, what was it, $30? Okay. So those would be my two equations. So for part C, I'd be interested in figuring out, when are those two things equal? When is it the same for both companies? What's the breaking even point? And if I was to solve this, what would your guys' preference be? Would you solve by graphing, by substitution, by elimination?
I think I would solve by graphing. I think that would be the easiest.
By substitution? By elimination? What would you guys' preference be? Would you solve by graphing, by substitution, by elimination? What would you guys' preference be? Would you solve by graphing, by substitution, by elimination? elimination, so you multiplied one of these by like -1 or something like that to get opposite y's? Or did you do substitution where you're saying, hey, this is already solved for y's, so I can replace like that? So technically either would work. I'll use substitution here. So I'll have 6x plus 30 equals 5x plus 50, and we'll solve, moving right along, bring the x's together. And I guess I can move the 30 to the other side as well simultaneously. And I get 6x minus 5x is x, and 50 minus 30 is 20. So it turns out 20 is the tipping point, 20 hats. But the question is, when is creative caps the cheaper one? How could I figure that out? I know they're the same at that point. Okay, so you're saying, like, let's figure out what 21 hats cost for each company, and then we know which one's more expensive at that point? Yeah, we could do that. So, like, I could figure out 21 hats. 6 times 21 would be, what, 126? So let's see. 6 times 21 plus 30 equals 126 versus 5 times 21 plus 50. So that's 105 plus 50. Is that 155? Is that right? That seems like a huge... What did I just do? I didn't add the 30. Okay. Thank you. That's why I've got you guys here. So, so it turns out Happy Hats is more expensive after 20, and Creative Caps is cheaper after 20. So we would say Coach should use Creative Caps for 20 or more hats. Or you could argue 21 or more hats, right? If you want to give preference to the fact that the other company has Happy in their name, right? Perhaps, I don't know. Here, check this out. If I solved this by graphing, we've got one equation, 5x plus 50, kablam, and another equation, 6x plus 30, kablam. And let's see, let me make this a non-square grid, so like a rectangular one. And watch this. I'm going to bolden these up a little bit as well, just for our online viewers' sake, am I right? Hey, represent online viewers. And let's see, so I scroll this down here. So this y-axis is our cost, right? Like our y variable was earlier. And x-axis is the number of hats. We can see that those are getting closer and closer to each other at some point. Clearly they're not graphing very well. Oh, that's not what I meant to do. I got to regraph those. Bam, with the new window. And it appears that at 20 hats, they're around $150, right? So you can see that that's the crossing point. Let's see, which one was Happy Hat or Creative Caps was the one at $50 starting rate, right? So let's just change this color to, I don't know, orange or something. So you can see that Creative Caps was more expensive because it's a higher cost, right, for the first bit, and then once it crosses that, it's underneath the purple line, so it's cheaper, right? So that's kind of a graphical solution there, which is kind of nice, like that. Actually, I guess the other analysis you could have done was just looking at the y-intercepts, right? You could have said this one starts a lot higher than the other. So this one, of course, is going to be the most expensive for low numbers of hats, and then it eventually becomes cheaper because it's got a shallower slope. So there's that as well. But anyways, friends, there's everything you need to know about buying baseball hats, apparently. My son, who's almost 2 years old now, can actually fit into my wife's hat size, which I think is interesting. He's got a giant head. So there you go. Have a great day, internet buddies. There we go.